Hello, everyone, and welcome to today's SANS webcast, Identifying Emerging Threats with Security Analytics, sponsored by AlphaSOC. My name is Carol Auth of the SANS Institute, and I will be moderating today's webcast. Today's featured speaker is Chris McNab, AlphaSOC co-founder. If during the webcast you have any questions for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Chris.
That's great. Thank you, Carol. First and foremost, I'd like to give Carol a round of applause for putting this together and working with us. So today, as it says on the tin, I'm going to be discussing security analytics, providing some open source free tooling. Free stuff is always good, and then describing some of the work that we've been doing over the last 5 years now over at AlphaSOC with security teams in particular, and how we can potentially help fill some gaps within coverage. And I'll dig into that later on. So on this first slide here, an important thing, I guess, to bear in mind, and just providing some color to this discussion, is that I think as an industry, we've really failed in a lot of ways from a kind of threat detection response perspective, and we're in this kind of status quo now where security teams have become used to just consuming threat feeds and intelligence, and adversaries and actors have been, evading detection by standing up new infrastructure and bypassing the kind of controls and the roadblocks that we've put in place to date. So really, what I've been trying to do at AlphaSOC for a number of years now is change that paradigm and empower the analyst. That's really what we're trying to do. Just a little bit about myself. So I've been fortunate enough to work in the security industry now for 20 years. I started out doing kind of offensive ethical hacking work, so a lot of penetration testing, red team work, infrastructure, web app pen testing historically. I then worked with O'Reilly to put together a pen testing book back in 2004, network security assessment. And then I've worked with them, over the last 15 years since then to put out a couple of updates to that book in particular. So my background really is a technical background. I'm not a sales guy. I'm not a marketing guy. I'm trying to make the world a safer place. And as I said at the top of the hour, work with security teams to try and move the needle with regard to detection response. In more recent years, I've been doing a lot more defensive consulting and incident response work. You may remember that a couple of years ago now, there were a number of GRU agents that were indicted for hacking Yahoo and a number of other tech companies. I was fortunate enough to chase those aforementioned agents through various tech companies out here on the West Coast. So I've got some firsthand experience of being in the trenches and going hand to hand with those types of actors. A real takeaway for me back in 2012, in particular, when a lot of those cases flared up, were that the existing tooling that was being used within SOCs, SIM tooling at the time, not really saw orchestration back then. A lot of that tooling really wasn't cutting the mustard or identifying these types of real adversaries within the environment. So in terms of the agenda for today, I'm just going to give a quick overview of some of the things we're doing over at AlphaSOC and why they're important and different from what some other or what a lot of other security vendors in this space are doing or attempting to do. I will then get into Network Flight Simulator, which is our open source free utility that you can use to evaluate your existing detection response coverage and visibility. Understanding the underlying SIM problems that cause those issues. So, if you look at a gap as being a symptom, what really is the underlying root cause, and how can we address that? And then that leads us on to the final piece here, which is then how we then work with hundreds of security teams to solve, some of these monitoring and visibility challenges and provide better visibility. So that's kind of the plan from an agenda perspective. So AlphaSOC, as a capability, we are really just in the business of processing raw network telemetry and generating meaningful alerts. So we operate then a cloud service, and we also have an on-prem version of our engine that the customers can deploy locally within their environments. And that engine then will pick up and take raw network telemetry, process it, do all kinds of heavy lifting, classification of the data and cutting it lots of different ways, and also then emulating and automating a lot of work that blue team and threat hunting folks will tend to be doing manually. We're trying to then start automating all of that. And through that deep analytics, we can then identify both known and unknown, aka emerging threats within environments. A lot of known threats is relatively straightforward to identify them through, using indicator lists and threat feeds, and just performing one-dimensional correlation against your data. But if you want to start to get into, flagging unknown threats, you then have to start performing all kinds of anomaly detection, classifying data in many different ways, and then looking for strange patterns or spikes within those data sets. As a business, for the last 5 years now, we've really been trying to change the game and collaborate directly with security teams. Just some interesting kind of data points here, I suppose, that differentiate us from a lot of other companies. The first is that our API is public, and the engine that we provide can be evaluated free of charge for 30 days. Later on in this webcast, I'll show you our Splunk app and demonstrate how easy it is to get up and running there and evaluate that tool within minutes in some cases. There's no mention of cyber or AI anywhere on our website. That's something I'm quite proud of. And then finally, our pricing even is public. We're very transparent in the way that we work with teams. So that's kind of, hopefully that gives you an idea of us as a business and the work that we're trying to do with regard to moving some of these conversations along and changing the game. A good way of kind of recapping that is to just say that the tooling that we build is built by technical folks and analysts and security engineers for analysts, and then we make a real effort to make those tools very easy to evaluate, inexpensive to use, and we really just want to get all of that engineering and that hard work that we put into the product for the last 5 years now into as many hands as possible and get as many security teams using this stuff. So that's kind of the plan. So FlightSim is our open source adversary simulation tool. Now, historically, what I found even firsthand is that it seems to me that CISOs have been spending a lot of their budget and their dollars on tools and security solutions that don't necessarily work very well in terms of flagging the types of threats that you really should be paying attention to. This has then led to all kinds of significant gaps existing in SOC coverage, and then the product of that dynamic is that you end up with these sophisticated actor press releases that we've all come to know and love and see. It seems to me almost on a weekly basis we're seeing a lot of breaches occurring. So PII data, password hashes, payment card details in some cases. That's kind of the net effect of this existing kind of dynamic that we found ourselves with over the last, from my perspective, over the last 20 years. But fortunately for us, we found that analysts and kind of technical security engineers within a lot of organizations are really starting to question that status quo and then implement better monitoring and security strategies. So the way that we then work with security teams is we then have published a network flight simulator, which then allows teams to emulate threats within their environments. And then in turn, that allows teams to quickly understand any blind spots that exist within their SOC, within their SIM tooling, and then obviously, start to think of ways to then address those blind spots through security analytics, better monitoring, whatever the case may be. So that's a little bit about the background of FlightSim. I'll now dive into a demo of the tool. So Network Flight Simulator, as it says here, is available from our GitHub repo, so github.com/AlphaSOC/FlightSim, and I've also published I think it's like a 10 or 15 minutes video that's up on our YouTube channel as well, that really digs into some of the features in a little more detail than what I'll go into today. So if I just then jump into a browser, so this then is our organization on GitHub, and in here we have different repos. I'll get into some of these other ones later in today's webcast. If I click into FlightSim, so FlightSim, we have then all the documentation here. As it says on the tin, FlightSim is a lightweight utility used to generate malicious network traffic. So it's a single binary that you can find pre-built under the releases tab in here. So here we then have the builds for Mac OS or Darwin, Linux and Windows. And then so from your perspective, you would then just pull down the respective binary and execute it. So if I then jump into a terminal window, so if I go into downloads and then run it in this kind of way, it will then just return some basic usage, and then from here you can use the tool to synthesize and generate different traffic patterns. In terms of the patterns themselves, let me just go back into here. Within the documentation, at the very bottom of the page, we have a full list of the modules that ship with FlightSim. So the whole point of the utility is that it's then going to generate and synthesize malicious network traffic from your local system out into the network. So if you're in, let's say, an enterprise organization and you're on a workstation, on like a user VLAN on a client system, you would then run this tool to generate kind of egress outbound traffic that then you would check within your SIM or your SOC kind of workflows to ensure that you are then able to pick up and identify some of these kind of malicious traffic types. So we have eight modules today that the product ships with. The first two here are our C2 callback emulation modules. So we're able to generate DNS requests to known C2 destinations. The way the tool is actually doing that is that it's generating a random sample of C2s using the cybercrime tracker. So if you were to just go to cybercrime-tracker.net, in here you then have a list of current C2s. I'm seeing stuff from the 17th of February for Tesla and Pony and different malware families in here. So this is just an open source, free to use source of C2 destinations. So the tool then is interacting with the cybercrime tracker, pulling down a random sample of C2 destinations, and then it's able to then resolve a number of those destinations and try to create DNS traffic to each of them. The second module in here is then performing similar C2 testing, but instead of using the cybercrime tracker, it's using an internal AlphaSOC API. We track C2s using Shodan and all kinds of other third-party integrations and APIs, and we then aggregate those in such a way that Network Flight Simulator can use them here. So the first two are basically generating C2 callback and beaconing traffic that we would then expect to see within your SIM tooling and your SOC kind of processes and workflows from like a blue team or DFIR perspective. The third module in here is then simulating DGA or domain generation algorithm traffic. So it's programmatically generating these random labels, and then it's attaching different TLDs to them, and then synthesizing and emulating DGA traffic. This fourth module is then testing for DNS hijacking support. So it's setting the name server of the system to ns1.sandbox.alphasock.xyz, and then trying to resolve arbitrary domains through that particular name server. So it's able to then test to see whether it's possible to set kind of different name servers within the environment that can then have unintended consequences. We then support port scanning testing, where the system will just randomly pick some internal IP addresses and then perform TCP vanilla port scanning against them. We perform sinkhole emulation or sinkhole traffic emulation, where we're then connecting out to known sinkholes. So within AlphaSOC, we track and understand sinkhole architecture or sinkhole infrastructure, whether it's Microsoft, Kaspersky, Symantec, other security providers. We track and understand their sinkholes, and we can then flag traffic to those and synthesize traffic to them as well. And then finally, the final two in here, the penultimate module is emulating spam bot traffic, so connecting out to different internet SMTP servers. And then the final module is testing for DNS tunneling. So that's just an overview of the modules themselves and giving you a brief kind of description of how the tool itself is running. If I go back into this terminal window, so once you have the binary downloaded onto your Mac, your Windows system, or you're running it like I'm here, you can then run the tool just with the run command in this way, and just invoking the tool in this way will then set off all of the modules and just run them in a serial fashion. So we can see here that FlightSim is preparing a random sample of C2 domains. It's going to pull those down from the cybercrime tracker, and then it's going to resolve the 10 of them. So in here, it's then generated DNS traffic to each of these domains. The next thing it's then doing is performing similar testing, but connecting out over TCP to particular IP port combinations. So again, in here, some of these you would expect to then find within Shodan or other threat feeds coming down from other intelligence providers. And then the system is programmatically generating DGA traffic, which it's now synthesizing and sending out through the local network interface. Once it's run this test, it will then perform the DNS hijacking simulation, and then we have the port scanning that it's now running. So it's just picked a random sample of internal IP addresses, and then it's trying to port scan each of them. I want to say that we send 20 or so packets to each of those, on different common TCP ports, like SMTP, HTTP, FTP, SSH, so on and so on. We then connect out to.
Chris, I'm sorry, it's Carol. I had a question come in during the demo, so I thought I'd go ahead and ask it.
Sure.
They say, what was the source to find the C2 domains?
So it's the cybercrime tracker, and I can put this into chat. Do you want me to put it into chat? So it's cybercrime-tracker.net.
Yes, thank you.
Good stuff. Yeah, so and I can just jump back into the web browser just real quick actually and show that. So is this domain here, cybercrime-tracker.net, and then the cybercrime tracker just then lists off all kinds of current C2s. This is by no means a super exhaustive list. It's just a good open source source of C2s that we then use within our flight simulator tool. So this then has finished running, those 8 modules. So it's performed then the port scan, it's performed the sinkhole testing, the spam bot testing, and the DNS tunneling testing. At this point, from a blue team kind of response perspective, you would then want to log into your SIM or look at your SOAR platform and actually hopefully then see alerting for DNS tunneling from this IP address or spam bot traffic, and so on and so on. If you want to run a particular module, so you can just go run -help or -h in this way, and you can invoke the modules independently as well. So if I want to run, let's say, the C2 DNS test just by itself, I would then go FlightSim run C2 DNS. And this then is going to rerun that testing, where again it reaches out to the cybercrime tracker, pulls down the domains, pulls down a random sample of 10, and then tries to resolve them. If I rerun it, we will then find that it tests for a different 10 domains each time. So it's useful to programmatically, and randomly generate this traffic, and that's one thing that FlightSim is very good at doing. And then again, you would look at your SIM and evaluate the coverage, and that's pretty much Network Flight Simulator. So as I've mentioned, it's free to download and pull down from our GitHub repo, and it's very easy to get it up and running in this way. Over the coming months, we're looking at adding new modules to this tool. So Tor testing, where we're going to generate Tor kind of onion routing traffic. We have lots of other modules that we want to add on. So if you are a GitHub user, also feel free to star the repo as well, just using the star functionality up here top right, where you can then monitor for updates and new releases. So on and so on. So that's Network Flight Simulator. Let me just jump back into my deck. Now, this was an interesting piece of real life user feedback that came in a few weeks ago. So a user of FlightSim had then realized that neither their Splunk ES or their Palo Alto networks threat detection capabilities were flagging traffic. So this just highlights and gives you a practical example of how there's just this disconnect within the industry between kind of incumbent sales and marketing folks pushing products, where then CISOs and security teams have this false sense of security and they believe that their environments are now safe. And it's only through running a tool like Flight Simulator that you can actually understand and measure gaps and then obviously come up with strategies to resolve them. So hopefully that gives you sufficient reason to look at pulling that tool down and running it within your own environments. Let's just now unpack what's actually happening here and try to understand the root causes and the reasons behind this. Now, the first thing to say is that architecturally, the vast majority of tools, if not every SIM and SOAR platform I can think of, are built in such a way that they're used to consuming threat feeds from external sources. So the system is then expecting content to come down. It's then going to perform a basic kind of one-dimensional correlation, and then it's going to generate or block events based on stuff hitting on the threat feeds and so on and so on. Now, this isn't a bad approach. Like, it's good to at least be performing that kind of basic one-dimensional correlation and kind of start somewhere. But it's very similar to the way in which legacy antivirus products are run, and this whole kind of way of using signatures, which we've now been doing for decades. And of course, that then leads to a couple of shortcomings. The first is what if you are patient zero? If you're patient zero, there's not going to be any threat intelligence. There's not going to be a threat feed item or indicator that will alert you to an attack. And then, of course, what if your threat feeds actually just aren't very good and don't contain the indicators that they should for you to then flag these types of events. So this obviously then leads to a significant gap appearing, and the important thing to bear in mind here is that adversaries are acutely aware of the way in which the modern SOC is set up. They understand that that blue teams and SOC analysts are using threat feeds and indicator lists. And a real takeaway here is that the actors that you should be concerned about, just like those GRU agents that broke into all those tech companies between 2012 and 2014, they're not reusing infrastructure or file hashes. They are standing up systems just to run very particular focus campaigns against organizations. So that hopefully that gives you a little bit of color and detail there, and at least food for thought around how do we, as an industry, how do we go from this place of having signature based kind of threat feed indicator driven systems towards having obtaining deeper visibility into our networks. Talking then about some difficult use cases that have been historically problematic to solve within kind of legacy and incumbent security tooling. It's hard to highlight and find odd clusters of network events from the same source. So looking within it then becomes like this kind of needle in a haystack problem, where you will have hundreds of millions of events each day coming into your SIM and into your kind of SOC, and then it's a case of processing those events to highlight kind of alerts or anomalies, and then loading those into kind of downstream processes. Now, an odd cluster of network events may look something like a connection event to a URL shortener, and then within a 5-minute period, we then would maybe see a connection event to a dynamic DNS name, and then maybe a young domain that has no kind of reputation. Now, each of these things in isolation isn't necessarily nefarious or bad, but if you see those 3 events occurring within, let's say, a 5-minute period from a single source, then that's something that the security team should be focusing on and looking at. In a similar way, flagging, identifying phishing attacks using homoglyphs is problematic. So if you have a brand name, like let's say it's like office365.com, you can use Unicode kind of transpositions and adjustments to that domain name to present something to a user that looks like office365.com, but really is a Unicode domain. Or maybe you would replace the O in Office 365 with a 0. And again, these are tactics that we've seen within recent months. There are plenty of campaigns I've seen where adversaries are setting up or spinning up phishing domains using different types of homoglyphs. And then I've mentioned traffic to young domains that have no reputation. That's always something that's very interesting, but again, historically difficult to identify within these data sets, because the tooling and the way that these systems are built is that they're depending on threat feeds and correlation. So you would need to then subscribe to like a newly observed domain feed in order to then figure out young domains within your data set, which is just a bit of a backward way of solving the problem itself. There are also threats that exploit known blind spots. So you have Tor, I2P, and Freenet anonymizing protocols that are used to bypass security controls and firewalls and establish internet connectivity and circuits outbound through security controls. We've seen within recent months a lot of data exfiltration over both DNS and ICMP channels that again are historically difficult to flag through use of threat feeds, if not impossible. And then DGA traffic, which again was another one of the data kind of threat types that we emulated through FlightSim. So these are all these 6 are really tricky to solve from a blue team kind of visibility perspective, and this then is really what we've been focusing on at AlphaSOC with the work that we've been doing. This just then recaps it. It's just not possible to solve many of these use cases, if not all of them, natively within SIM and SOAR products, as the way that those products and those systems operate and are built just isn't conducive to succeeding with this regard. So now pivoting into what we've been doing at AlphaSOC and the way that we work with hundreds of security teams all over the world. So we operate an analytics engine. This really is, our core focus and a thing that we work day in, day out improving. The engine itself can be run either on-prem. We have a single Linux binary that we can distribute that can be run in a container, or very easily stood up on a VM within an environment. But most of our users do just consume our cloud service that we then operate in like a multi-tenant fashion. So looking at this architecture diagram, on the left-hand side, we then have telemetry, network telemetry sources. So the engine can process DNS telemetry. Now these are DNS kind of egress DNS events leaving an environment. So when a workstation is resolving various domains, if you're capturing that information, whether you're using Bro IDS, Suricata, whether you're logging, whether you have DNS debug logging enabled on your domain controllers, whatever the case may be, if you're capturing that telemetry, you can then ship it up into Splunk or through our network flight recorder tool, which is just an open source lightweight agent that we put together. You would then get that material into the engine. We then perform all kinds of heavy lifting against that data, and then we generate alerts which are then kicked out on the right hand side. The other telemetry sources are then IP events, so we can process firewall logs, we can process deep packet inspection or IDS logs. Again, something like the Bro con.log file, we can easily parse and process that. And then finally, we also now have HTTP processing, where you would then load in HTTP events that are either being captured on the wire or coming in through web proxies or other apparatus that you may have deployed. And the cool thing there then is, in terms of that kind of three-layered approach, IP, DNS, and HTTP, we're able to then flag anomalies and campaigns across different layers. So for example, we can flag things like beaconing to a young suspicious domain, where we're then able to perform timing analysis to understand whether the requests from that source to that destination are then falling into a regular pattern. We then who is all of the domains that we see within the environments that we monitor, which then allows us to flag whether a domain is young or old, and then we have an understanding as to whether a TLD is suspicious or not based on how rare it is, right? So if let's say we see weird traffic to a particular domain within like the .biz TLD, we're going to treat that differently to let's say we were looking at like .com traffic in particular. So that's an example, a very quick example of the kind of heavy lifting that the analytics engine is doing, and it's just not possible to perform this type of processing natively within Splunk or other systems, which is why we have to basically ship that raw telemetry off to the engine. We then do all the heavy lifting and the processing, and then we generate alerts that are provided in either JSON or CEF formats, and we can get those back into other SIM and SOAR platforms very easily through syslog and through syslog in particular. Mentioning and just kind of recapping with these 6 icons we have to the left and the right, 3 on each side. These are all native integrations. So we have native kind of plug and play integrations for Splunk and Elastic on the left, and then Splunk, Demisto, and Greylog, which is an Elastic kind of SIM system on the right hand side. So if you do have any of these technologies, it's very, very easy to get up and running. It would take a matter of minutes to get set up with those, because we do have an integration natively within the Demisto system. We have a content pack within the Greylog marketplace, and then our app is published within the Splunk base app store as well. That's not to say that if you're on, Logarithm, ArcSight, QRadar, whatever the case may be, that's not to say we don't support those. We absolutely can ship our events and our data into those platforms. It's just a case of doing a little bit more plumbing and legwork to get those alerts, rendered and into your existing flows and dashboards. So that's just an overview of the architecture and the way that we work with security teams to kind of add that analytics capability into their workflow. Here I have an example. It's very timely, actually. This was a tweet that we put out last week, and basically what happened was that on the 15th there was a Fin7 APT Word macro downloader that we saw in the wild, and the domain that downloader was using to then check into a C2 command and control destination was this logitech-cdn.com domain. And because of the way that the analytics engine works and basically deconstructs and performs this kind of layered analytics and assessment of every single FQDN, it then flagged this traffic as a risk 4 event. So risk 4 within our system is a high severity issue. So our risk scoring goes from 5 down to 0, 5 being critical, 4 being high, 3 being medium, 2 being low. This was generated completely programmatically as an alert. This domain didn't appear on any threat intel at the time. And this just really demonstrates in a very clear way the capability that we're able to add through doing that kind of multi-layered classification of FQDNs and IP addresses and URLs in particular. So in this case, the Wisdom subsystem within the engine flagged the domain as being an imposter. So it recognized that logitech-cdn.com wasn't a legitimate Logitech domain. And then because we're actively whoising all of the domains that we see within the environments that we monitor, we were then able to also flag it as a young domain. Just as a little side note there and data point, I want to say as a business, we spend probably just over $10,000 a year just on whois credits alone. So this just then gives you an idea of how much processing we're then doing on behalf of our users. This then is a second real life we're able to highlight and uncover within another customer environment. So this is from August of last year. And it's a little bit pixelated here, but hopefully you can make it out that this is a Rackspace phishing domain. So rackspace.co using a Unicode homoglyph. And the domain also then has a Let's Encrypt certificate to boot as well. So this again was highlighted through the analytics engine. It flagged the domain as being young and an imposter, a known kind of homoglyph or a homoglyph of a known brand. And again, we were able to then flag that type of activity. So, outside of these two examples, we commonly see red teams setting up infrastructure that we're able to flag. And in some cases, we also then pick up on state-sponsored kinds of activities as well, which aren't as common, but certainly it's useful to have that kind of coverage and visibility. I'll now just go over a quick demo of our Splunk app, just to kind of show off some of like the UI elements and highlight some of the unique features and the things that you can consider building out within your SOCs. The app itself is available from the Splunk App Store, aka Splunk Base. You can also hit this alphasoc.com/Splunk URL, which will take you straight to Splunk Base. And again, we have another 30-minute detailed demo of the tool, which just steps through setup and configuration, so forth and so forth. So let me jump back into here. So this then is the Splunk Base page, which just shows, once you're logged in, you can download it. The first time that you run the app, it will self-provision an API key. There's no need to talk to any sales folks. You can get up and running and evaluate the tool within minutes if you already have Splunk and your data is formatted correctly. So the way that the Splunk app looks practically is that we have this threat hunter view where we're then describing C2 events within an environment, and this is just our demo site, so this is all just demo data that I'm presenting here. I've mentioned flags that come in from our Wisdom subsystem within the app. So we have a ton of different flags that we can attach to events. Here we have then FreeDNS, which indicates that the system recognizes that this domain is a dynamic DNS destination. C2 recognizes that this domain already exists on a threat feed and is flagged to C2. We're able to flag things as sinkhold if they resolve to IP space that is known to be run by Microsoft Kaspersky for sinkholing purposes. We're able to flag IRC servers and so on and so on. In terms of an exhaustive list of flags, if I click into our documentation, this is just alphasoc.com/docs. In here we have the raw alert format page. And these flags are the same whether you're using our Splunk app or whether you're just pulling down JSON alerts from the back end. So we're able to then flag all kinds of different features or highlight all kinds of different features within data. Flag C2 traffic. I'll make this a little bit bigger so it's easier to read. C2 traffic, crypto mining, crypto jacking. We resolve all of the domains that we see against multiple threat blocking providers, and then if a number of them return a positive result, we'll then flag that as interesting. We're able to classify, dropper domains, known phishing domains, and so on and so on. Google Safe Browsing, we correlate the traffic with safe browsing. We have third-party integrations with multiple sandboxing engines. So we're able to then take FQDNs and IP addresses within the data sets that we're processing and see whether there are known malware samples associated with those. And if there are, then we attach the sandbox flag, and we can then combine that flag with other flags where maybe we would look for, let's say, sandbox and FreeDNS, and we would maybe flag that as interesting. I remember there being an example in here. Let me find it. So known bad dynamic DNS provider traffic. So in here the system is recognizing then that f3322.net is a known dynamic DNS destination in China, and then sandbox means that the FQDN itself is then also generating a positive score on multiple sandboxing engines. If I then open up VT in particular and provide VirusTotal with this FQDN, we then get this kind of positive score from VT where we can then see the individual samples and so on and so on. Also within the Splunk app, it will then flag things like imposter traffic to a young domain impersonating a known brand, which is then similar to the other two examples I had shown. So the system here is recognizing then that Amazon AWS EC2.net is an imposter domain. It's not really a legitimate Amazon AWS destination, and then the domain also is flagged as young. So we have these tooltips within the app. So the domain was registered less than 60 days ago, and we then combine these two features to then flag this as a high severity issue, completely programmatically with no, as I said, no threat feeds or one-dimensional correlation. This is basically programmatically taking these kind of weak signals, and then if we see certain combinations of those signals, we're then upgrading the severity and presenting it to the team to dig into. Practically, from a threat hunting perspective, the final thing to mention here is that practically what we find with users that start using security analytics and doing this kind of processing is that at first they have a number of high and critical severity issues. infected systems that require attention. But as time goes on and the general kind of safety and security of the environment improves, we then find that many of our users are just presented with maybe a handful of medium severity issues on a given day, and then a longer tail of low severity issues. So from a threat hunting perspective, that's then useful because you then have this capability to flag, let's say, beaconing to a suspicious domain, where the system then is recognizing that these timing deltas between requests are falling into around a 60-minute kind of cycle. And the system's also then recognizing, okay, .info is a weird TLD, and the FQDN itself is unreachable. We try and resolve the FQDN, look up its name servers, who is the domain, and if those tests come back negative, we then flag it as unreachable. This then is indicative of traffic that's being generated programmatically, whether it's within JavaScript within a browser or some other process that's running on the client system, which then allows us to quickly differentiate between human-driven clicking and traffic versus computer-driven events. So the system then has this whole spectrum of capabilities and uses, from flagging clear phishing attacks, spear phishing, watering hole attacks, and significant, like, severe problems, all the way through to threat hunting applications where you can then start to dig into these weaker signals and then hopefully achieve that kind of warm fuzzy feeling where, because you do have the visibility and the coverage, and this is then coming up largely negative, that you are then more confident in the configuration of your environment and the way things are set up. So yeah, so that's how things look once they're rendered. You can replicate this kind of rendering within Elastic, ArcSight, QRadar, SOAR platforms and tools. That there are many different ways of consuming the AlphaSOC alerts. So that's pretty much what I wanted to talk about with that regard. The final thing.
Sorry, you may have addressed this. This came in about 10 minutes ago, but someone asks, once you generate the alerts, how do you remediate or block the suspicious traffic?
How do we?
Remediate or block the suspicious traffic.
So the system really is just taking telemetry, processing it, and then generating alerts that then the SOC would then work with. Now, the way that things are starting to move with adoption of SOAR and kind of orchestration layers or processes are that alerts can be fed into orchestration in such a way that then the indicators can be used to reconfigure firewalls, move infected machines into quarantine VLANs and so on and so on. So it really depends on the sophistication and the maturity within your SOC. At least from a manual perspective, you could at the very least, open a ticket and feed these indicators and these domains into kind of manual processes, which is what a lot of our customers do. But the system by itself, we're really just in the business of generating alerts that are accurate and meaningful, and it's then up to the SOC and the security team and then the response capability within a customer environment to then take that material and then actually respond, block, quarantine, triage the events themselves. The final thing I just wanted to mention was network flight recorder. So so NFR is also within our GitHub organization, and this then is a lightweight tool that you can use to interact with the AlphaSOC API just from the command line. You can set up your AlphaSOC API key using NFR. You can then submit data to the engine for scoring. You can retrieve alerts in JSON or CEF format for escalation and processing. This almost is like a Swiss Army. It's like the AlphaSOC Swiss Army knife. So if you're not using Splunk, feel free to take a look at this. And then finally, if you are using Elastic, we have Packet Beat support within our API and the service that we run, where you can then configure Elastic Packet Beat to ship data to us natively as well. But feel free to reach out to us, support@alphasoc.com. Get in touch regarding, deployment, like your requirements, the systems that you're running, and so forth and so forth. The final thing to mention with regard to NFR is that it can either be run as a sniffer and pick up events on the wire, or it can process events from disk. So if you have, bro dns.log or con.log material, you can have NFR monitor those logs and then ship that material up to the API for scoring. And then once NFR is running, this then is the kind of JSON format that it will generate alerts using. So you can then take this alert material and then feed it into other processes and try to kind of automate and orchestrate around the alerts that we generate. So that's pretty much the demo piece. Let me just jump back into my slides. So as a quick recap, the best way of thinking about the capability that we've built and what you should maybe be striving for and looking to build and roll out within your environments is getting towards three-dimensional processing. So, the first dimension is just this plain, vanilla, correlation with threat feeds, which, every security product and SOC, SIM product under the sun supports. And that's kind of your starting point. From there, the second dimension is then getting into timing analytics, identifying beaconing patterns, doing volumetric analysis to figure out, spikes in activity, exfiltration of data, and so on and so on. And also deep feature analysis in there as well. So, figuring out then whether a domain is perplexing or not, performing like a Shannon entropy calculation on a domain. That's useful to figure out whether a domain has been computer generated and randomized, or if it is, like a regular kind of English word. And then the third thing that we're doing within AlphaSOC that many, if not all of our competitors are failing to do is then this kind of active polling of third-party APIs. So we're actively then taking the IP addresses and the FQDNs that we see within these environments, and we're then correlating, or we're then actively checking, sandboxing engines with who is in the domains, and just performing that kind of, active outbound work to then gather better signals and get a better feeling for what's going on. In terms of then takeaways, so from here, if you use the Network Flight Simulator tool, you can quickly understand gaps in your coverage, and then you can look to bolster and fill those gaps using security analytics. And I'll turn it over to Carol now for some Q&A.
All right, thanks for that great presentation. We do have a couple questions ready for the Q&A. However, if anyone has a question for our presenter, please enter it into the questions window now. Our first question is, do you have sight into SSL traffic, or do you work with a third party to provide that?
So we are we're building out SSL TLS coverage within the engine right now. Primarily focusing on JA3 checking and processing to then flag, malware and command and control infrastructure and weird client systems using JA3. So that's the current plan for SSL /TLS. From an HTTP perspective, if you do have, Bluecoat, Zscaler, these other proxies deployed internally, and then that material is then available to process, we can work with HTTP traffic that way.
All right, thanks. Does it detect the puny coded domains?
Yeah, absolutely. So if you were to take, let's say, Amazon AWS, and then you were to puny code it, maybe replace one of the A's with a Unicode A, the system would recognize that that was then an imposter domain if it's not registered to Amazon itself. So the other neat thing we do with our imposter detection is if a domain doesn't exist, let's say a user fat fingers AmazonAWS.com and the domain doesn't exist, we won't escalate that or flag that as a significant risk. Because of the fact that we are able to who is the domains and figure out which actually do exist and look at the age of them as well.
All right, thank you. Is it possible to send data to the analytics engine from Bro IDS or Suricata?
Absolutely. So so NFR, if I go back into my browser, so NFR, you would just use network flight recorder. It's a single binary for Linux or Windows, and then you would configure it to monitor, your DNS.log or your con.log, and we can do the same thing on the Suricata side as well.
All right, thanks. Is there an on-premise version of the analytics engine?
Yes. So most of our customers do consume the cloud service, but for defense contractors and some of the banks that we work with, we deploy then the engine on-prem. The way practically that works is that the engine is just a single Linux binary. We've been able to miniaturize it down to a very lightweight piece of software that can run locally, and you would then deploy it either within a container or atop of a Linux VM, and then within the Splunk app and the other tooling, it's very easy to then point those systems at the on-prem engine instead of consuming the cloud service.
All right, thanks. And this next one might be asking about a different vendor, I'm not sure, so I won't say specifically, but how does the AlphaSOC Analytics stack compare with others?
So a lot of other vendors that are doing security analytics or like next-gen cyber AI stuff, a lot of those folks are performing kind of two-dimensional testing or assessment where they are looking for spikes in volume and beaconing, so on and so on. The challenge is from an analyst perspective, if you're not doing the third dimension and pulling down material from sandboxing engines, understanding whether a domain really exists or not, whether it's being blocked by DNS threat blocking providers and so on and so on. If you're not doing that extra work, you end up with output from those tools where you still have to manually do all kinds of analysis and dig in and spend and allocate a lot of cycles. So other tools, basically a good way of looking at it is that other tools perform two-dimensional assessment, and the work that we've been really championing and focusing on within the analytics engine and the software we've been building is then going that extra step and pulling down additional context from third-party sources. And the important thing to bear in mind there is that we're then able to automate work that an analyst would otherwise have to do themselves after the fact, if they're using other tooling. So there's all kinds of benefits from an efficacy perspective with letting the engine just do all the heavy lifting and process the data, and then providing these kind of, what I like to call kind of accurate and meaningful alerts back into the blue team and the SOC that can then be used. And then finally, from like an alert fatigue perspective, we're very conscious of alert fatigue. So the way we've set the system up and the volume of alerts it generates, it doesn't generate hundreds or thousands of alerts. It really highlights and generates, even within, I want to say that there's a particular environment we monitor that has, I want to say it's like 10 or 11,000 employees. And each day it generates maybe a handful of high and critical severity alerts across that entire estate, which is always then nice to see from a SOC blue team perspective, because you're not getting flooded out with tons of noise.
Thank you. Someone says, thank you for the great presentation. I think we have time for one more. We're using ArcSight. How can we gather alerts from the analytics engine?
Yeah, so the system, as I've mentioned, we have native integrations, Splunk, Graylog, Demisto, those are plug and play integrations. If you are using ArcSight within Network Flight Recorder, we have an output option to output the alerts in CEF, common event format, and NFR will also then ship those using syslog off to an ArcSight syslog collector, and then you can get the material into ArcSight, and that's actually the same for really any modern SIM, whether it's ArcSight, Logarithm, QRadar, Alien Vault. We have users who are set up with all kinds of different SIMs. So a good way of looking at the AlphaSOC capability is it's this nice, easy to use, or hopefully easy to use additive element where you can then improve your coverage and your visibility through processing all of that raw telemetry through the engine, and then shipping the alerts into whatever SIM and SOAR products you may already have deployed.
All right, well, that's all the time we have for today. Thank you so much, Chris, for your great presentation, and to AlphaSOC for sponsoring. Great, and to AlphaSOC for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcast. Until next time, take care, and we hope to have you back again for the next SANS webcast.